when those denominators are made up of polynomials. We have already said to find the LCD, we use all factors with highest exponents. However, in order to use all factors, this means we must first factor each of the polynomials. Let's take a look at some examples where we have to do just that. In this problem, we want the least common denominator of these two polynomials. To find all the factors, we need to factor each polynomial first using the AC method. Multiplying to negative 18 and adding to 3 will be 6 and negative 3. Because we have a 1 in front of x squared, we know our factors are x plus 6 and x minus 3. For the other polynomial, using the AC method, we multiply to negative 21 and add to 4. This is done with 7 and 3 if the 3 is negative. This means we have x plus 7 and x minus 3. Now that it's factored, we can find the least common denominator, or least common multiple, by listing out all the factors with highest exponents. We see we have a factor of x plus 6. We also have a factor of x minus 3. We also have a factor of x plus 7. Notice, however, we already have x minus 3 in our list. Thus, there is no reason to list it twice. We would want to check to make sure we're using highest exponents on each of these factors. Because none of the factors have any exponents on them, we also don't need any exponents in the least common denominator. The least common denominator, then, of x squared plus 3x minus 18 and x squared plus 4x minus 21 must be x plus 6 times x minus 3 times x plus 7. Let's take a look at one more example where we find the LCD by factoring. Using the AC method on these polynomials, we would want to multiply to 25 and add to negative 10. This would be negative 5 and negative 5. This is interesting to us because the negative 5's match. It means we have a perfect square. Recall that we factor a perfect square by taking the square root of the first term and the last term, x and 5, and the sign from the middle. We can factor our second polynomial using the AC method as well, multiplying to negative 20, adding to negative 1, and this is done with 4 and 5, where the 5 is negative. Because we have a 1 in front of the x squared, we have x plus 4 times x minus 5. Now that we know the factors, we can list all the factors in the least common denominator. Notice we have a factor of x minus 5. We also have a factor of x plus 4. There is no need to list the x minus 5 again, as we already have it as part of our least common denominator. All that is left to do is attach the highest exponents to each factor. Notice one of the x minus 5's had an exponent of 2. This means in the LCD, the x minus 5 must also be squared. There are no exponents on the x plus 4 factors, and so we don't need one on the x plus 4 factor. This gives us our least common denominator of x minus 5 squared times x plus 4. Finding the least common denominator is simply done by factoring all of the polynomials, listing all the factors only once, and then using highest exponents.